People ask me pretty regularly how to run AI at home cheaply, and the honest answer is not a model name or a hardware spec. It starts with a cost that almost nobody in those guides actually mentions. So before I show you the options and the math, I want to name that hidden cost because it changes everything about how you think through this decision. Running AI at home is not just about what you pay at checkout, it is about three costs that each show up in a different part of your life. Once you see all three clearly, the decision gets a lot simpler, and the answer you land on might surprise you. The cost most people forget. The guides I see online usually focus on the upfront hardware cost. They say buy this graphics card, download this model, and you are running AI for free. But that is only one of the three real costs, and honestly, it is not always the biggest one. The cost they skip is power. A graphics card running inference draws real electricity every hour it is on. If you are running it lightly, that might be a few dollars a month. If you are running it hard, that number climbs fast. And the third cost is the one nobody wants to admit exists: your time. Setting up a local model is not hard, but it is not nothing either. You are installing software, choosing a model, troubleshooting the first few runs, and then keeping it working as things update around it. That time has a real value, even if it does not show up on a power bill. Isn't extreme point indifferently for untrambian? So let me walk through the three real costs one at a time, starting with hardware. The good news is, you do not need to buy anything new if you already have a reasonably modern graphics card. A card with 8 GB of VRAM or more can run a wide range of smaller quantized models today. The cutoff used to feel high. It does not anymore. If you have an older gaming card sitting in a machine you already own, you have the hardware cost at zero because you already paid for it and you would own it whether you ran models on it or not. If you are buying something new specifically to run AI, then you are making a capital purchase, and that cost is real and needs to go into your math. A used card with enough VRAM is almost always the better move for pure economics compared to buying new. Concerns models and what that means. The other half of the hardware picture is the model itself. The models that get the most attention are the large ones, the ones that need tens of gigabytes of VRAM to run at full precision. But there is a whole class of smaller quantized models that are designed specifically to run on modest hardware. Quantization is just a technique that reduces the precision of the numbers the model uses internally. You lose a small amount of quality, and you gain a very large reduction in the memory you need. A quantized 7 billion parameter model can run comfortably in 8 GB of VRAM and still do a very solid job on most text tasks. The output is not as sharp as the biggest models, but for most of what people actually do at home, writing, summarizing, answering questions, the difference is small enough that it does not matter in practice. Running on CPU for tiny tasks. If you do not have a decent graphics card at all, you still have an option, but the trade-off is speed. You can run very small models on a CPU. It works, it is just slow. If you are asking a model a question and you are okay waiting 15 or 20 seconds for a response, a CPU setup will get you there. The model sizes that run tolerably on CPU are small enough that quality is noticeably limited. But for a narrow set of tasks, quick summaries, simple lookups, light text cleanup, they are genuinely useful. I would not use a CPU setup for anything I needed to run dozens of times a day. The time cost of each slow inference would eat you alive. But for occasional light use, it is a valid zero hardware cost starting point. The power cost, honest numbers. Now let me be honest about the power side, because this is where a lot of home setups get surprised. A modern graphics card at full load draws somewhere between 150 and 350 watts depending on the card. If you are running inference for an hour a day, that is a small number, maybe $1 or $2 a month depending on your electricity rate. If you are running it for 4 or 6 hours a day, the number starts to matter. And if you are running a server that is always on and always available, you are looking at a meaningful monthly electricity cost that compounds over time. The key point here is that power cost is roughly proportional to how much you actually use it. It is not a flat monthly fee. It scales with your real usage, which makes it behave more like a metered cost than a fixed one. The time cost, honest accounting, the time cost is the one I want you to take seriously because people almost universally underestimate it. Getting a local model running the first time is not hard if you follow a good guide. You are probably looking at an hour or two to get something working, but that is not the full picture. You will spend time choosing between models because there are dozens of options and the differences are not always obvious until you have tried a few. You will spend time when an update breaks something and you need to figure out why. You will spend time learning the quirks of the tools that sit around the model, the server software, the interface, the API layer if you want to call it from other things. None of this is terrible, but it is real and it is ongoing. For people who genuinely enjoy this kind of tinkering, it does not feel like a cost at all. For people who just want a tool that works, it is a real recurring tax. The metered API as a real option. Now I want to talk about the alternative honestly, because a lot of local AI content treats the metered API as a cheat or a compromise. It is not. A metered API means you pay for exactly what you use and you own no hardware and do none of the maintenance. You send a request, you get a result, you pay a small amount per request. For many tasks, the per request cost is genuinely tiny. A typical text request to a capable model costs fractions of a cent. If you are doing 100 requests a day, you are probably spending $1 or $2 a month. And you are getting access to models that are sharper than anything you can run on modest home hardware without spending a single hour on setup or maintenance. That is the trade-off. You get better quality and zero setup time, but you pay per use instead of paying upfront and drawing power. When running local is actually cheaper, so when does running local actually come out ahead on cost? The math works in your favor when you run a lot of jobs steadily and consistently. Here is why. Your hardware cost is fixed once you own the card. Your power cost is roughly fixed per hour of use. So the more jobs you run per hour, the lower your cost per job becomes. If you are running hundreds of inference calls a day every day, the per call cost of local hardware drops to a small fraction of what a metered API would charge for the same volume. The crossover point depends on your specific hardware cost, your electricity rate, and your usage volume. But the general shape of the math is consistent. High steady volume tilts the economics toward running local. Low or spiky usage tilts them toward paying per use. When the API genuinely wins, the flip side is also true, and I think this is the more honest thing to say for most people who are just starting out. If your usage is spiky, meaning you run a lot of inference for a day or two and then barely touch it for a week, a metered API will almost certainly be cheaper than running your own hardware. The reason is that your hardware and power costs are mostly fixed per hour the machine is running. If you set up a local server and then leave it idle for days at a time, you are paying for hardware you are not using, and you spend hours setting it up and keeping it running. A metered API charges you nothing when you are not using it. For occasional bursts of use, that zero idle cost is the whole argument. Prepare in plain terms. Let me put the comparison plainly. If you already own the hardware, you run it hard and steadily, and you genuinely enjoy the setup and maintenance side, running local is almost certainly the right call. Your marginal cost per job is very low. If you are buying new hardware specifically to run AI, you need to be honest about how much you will actually use it, because the break-even time is longer than most people expect. If your use is occasional or unpredictable, the metered API removes the fixed cost entirely and charges you only for what you actually do. Neither option is free, neither option is universally better. The right answer depends on your actual usage pattern, what I actually run and why. In my own setup, I run a mix of both, and the split is deliberate. I run a local model on my own card for tasks I do at high volume, batch jobs, things I run dozens or hundreds of times in an automated pipeline, tasks where the metered cost would add up quickly at scale. For those, the marginal cost of local inference is well below what I would pay per call on a metered API, and the hardware was paid for a long time ago. For tasks I do occasionally, one-off questions, things I need a sharper answer for than my local model can give, or tasks I do in a burst and then not again for weeks, I use a metered API. I do not feel any guilt about the mix. The goal is to get the work done at a sensible cost and with a sensible amount of my own time spent keeping it alive. The tool is not the point, the outcome is. A note on always on setups. One more thing worth naming. Some people want a local AI setup that is always on and available at any moment from any device. That is a legitimate goal and it is achievable, but it changes the economics significantly. An always-on server draws power continuously even when you are not using it. If you run a small home server for this purpose, you are looking at a baseline power cost every month, regardless of how much you actually use the model. For people who query the model regularly throughout the day, that makes sense. For people who use it 3 or 4 times a week, the math does not work as cleanly. It is worth being honest about whether you want always on because it is genuinely useful or because the idea of it feels cool. Both are valid feelings, but only one of them closes the economics. A word on model quality at home. The last thing I want to address is quality because it matters to the decision. The models you can run on modest home hardware today are genuinely good. They are not the best available. The biggest hosted models are still ahead on the hardest tasks, nuanced writing, complex reasoning, tasks that require a lot of breadth. But for the everyday tasks most people are actually doing at home, the gap is smaller than it used to be and still closing. If your use case is writing assistance, light code help, summarizing your own documents, answering questions from a knowledge base you feed it, a well-chosen quantized model on decent hardware will serve you very well. The honest caveat is that quality expectations matter. If you are comparing to the best hosted models, you will notice the difference. If you are comparing to doing the task by hand, local models look excellent. The decision is yours to make clearly. So here is where I land. Running AI at home cheaply is absolutely possible. The hardware cost can be near zero if you already own the right cards. The power cost is real but modest if you are running it sanely. The time cost is the one that surprises people most, and it is worth taking seriously before you commit. A metered API is not a compromise or a failure. For spiky or occasional use, it is genuinely the better economic choice. For high-volume steady use on hardware you already own, local almost always wins on cost per job. The cheapest option is not the same for everyone. It is the one that matches your real usage pattern, not the one that sounds most impressive in a setup video. If you want more honest, no hype breakdowns of how I actually think through these decisions, subscribe and follow along. Thanks for watching and I will see you in the next one.